Main sequence star. Main sequence stars are the most common stars in the universe, including our own sun. They spend most of their lives turning hydrogen into helium deep inside their cores. This steady process creates the light and heat they give off. A star remains in this stage for millions or even billions of years, depending on its size. Smaller stars burn their fuel slowly, while larger ones use it much faster. Red Dwarf. Red dwarfs are the smallest and coolest main sequence stars. They shine with a faint reddish light and use their fuel so slowly that many can live for trillions of years, much longer than the current age of the universe. Although they are difficult to see with the naked eye, they make up the majority of stars in our galaxy. Many recently discovered planets orbit these quiet, long-lasting stars. Yellow Dwarf. Yellow dwarfs are medium-sized stars with stable temperatures and brightness. The Sun belongs to this group, even though it actually appears white from space. These stars provide steady energy for billions of years, giving nearby planets enough time for complex environments to develop. Their balance between size and lifespan makes them especially important in the search for life beyond Earth. Blue Giant. Blue giants are extremely hot and very bright stars. Their blue color comes from their incredibly high surface temperatures, which can be several times hotter than the Sun. They burn through their fuel at an amazing rate, so despite their enormous size, they usually survive for only a few million years. Their powerful light can outshine thousands of smaller stars combined. Red Giant. Red giants are aging stars that have nearly used up the hydrogen in their cores. As their internal balance changes, their outer layers expand dramatically, making them much larger than before. Although their surfaces become cooler and appear red, they remain very luminous because of their enormous size. Billions of years from now, the Sun is expected to enter this stage. Supergiant. Supergiants are among the largest stars ever observed. They can be hundreds or even more than 1,000 times wider than the Sun. These stars exist because they began with tremendous amounts of mass. They produce heavier elements inside their cores and play a major role in shaping the universe. Many eventually end their lives in spectacular explosions. Red Supergiant. Red supergiants represent one of the final stages of the most massive stars. They are enormous, cool on the surface, and incredibly bright. Famous examples include Betelgeuse, which is so large that if it replaced the Sun, it would stretch far beyond the orbit of Mars. These stars are unstable and can explode as supernovas, scattering newly formed elements across space. Blue Supergiant. Blue supergiants are massive stars that remain extremely hot while reaching immense sizes. They produce powerful stellar winds that blow material into surrounding space. Their short lifespans are filled with intense nuclear reactions, making them some of the brightest objects visible across great distances. They often become the ancestors of some of the universe's most dramatic explosions. White Dwarf. White dwarfs are the small, dense remains of stars similar to the Sun. After a red giant sheds its outer layers, only the hot core is left behind. Even though a white dwarf is roughly the size of Earth, it can contain nearly as much mass as the Sun. It no longer creates energy through nuclear fusion and slowly cools over billions of years. Neutron star. Neutron stars are created when massive stars collapse after a supernova explosion. Gravity compresses the remaining core so tightly that protons and electrons combine into neutrons. The result is an object only about 20 kilometers across, but containing more mass than the Sun. A single teaspoon of neutron star material would weigh billions of tons on Earth. Pulsar. Pulsars are rapidly spinning neutron stars that send beams of radio waves, light or X-rays into space. As the star rotates, these beams sweep across the sky like the beam from a lighthouse. If Earth lies in their path, scientists detect regular pulses arriving with incredible precision. Some pulsars spin hundreds of times every second, making them among the most accurate natural clocks known. Magnetar. Magnetars are a rare type of neutron star with the strongest magnetic fields ever discovered. Their magnetic force is so powerful that it can affect atoms from thousands of kilometers away. From time to time, magnetars release enormous bursts of high-energy radiation that can briefly outshine almost everything else in their region of space. Even though they are rare, they help scientists understand matter under the most extreme conditions.